Hello everyone, this is a video lecture for Calculus 2 section 9.2, direction fields, and eventually Euler's method. So direction fields are where you plug in an x and a y, kind of like in a table format. You're used to that, right? But now these are both inputs and you get y prime as an output. So instead of like back in the day when we had x and y, you plug in a 1, 2, and a 3, and a 4 and all that stuff, and you get your answers. Well, now I'm going to say I plug in whatever answers I want, my numbers here as I want, and I get answers for each of those as a y prime. So this xy is a point that I'm going to be plugging in, and my y prime is my answer is a slope. It's the slope of a line, and so each time I have a point, it has a slope attached to it. Something like this. Say I have a point here, and I said, hey, guys, the slope is equal to 2. And you would say, oh, okay. Whoop. There you go. And you make a line. But what if I had a point like right here, let's say, and I said, hey, guys, the slope is equal to -7. And you're like, oh, whoosh, something like that. And I have another point like right there. I say, hey, guys, the slope is equal to 0. And you're like, oh, it's a flat line. So my point is that you can make all these different little lines at the points that they specify, or rather you specify. Cool. So what does that look like in practice? So 92001. Let's start with the most complicated. That's just exactly like what the homework would do, right? It says, hey, question number 1, let's go ahead and make it really terrible. I don't make the homework up, okay? I just administer it. So this is a crazy slope formula. Again, though, I want to find out what my slope is at these particular points and then graph it. So I'm going to pick some points myself. What about 0, 0? I'm going to literally plug it in. So 0 here and 0 there. Notice that I have 0 times anything is definitely going to be a 0. 0 times 1. Or I'm sorry, 0, 1. So it's 0 and a 1. Regardless of what's going on here, I got right here a 0. 0 times anything is 0. What if I have a 1, 0? So this is a 1 now. That's a 0. Well, cosine of 0 is a 1. So all of this right here is a 1 times 16 is actually a positive 16. And then I got 1, 1. Let's try that. So I got 1 cosine of 1 pi. Cosine of pi is a -1. So -1 times 16 is a -16. And you can keep going. And you'll keep going this way. I'm just kind of showing you how you plug these in and get some answers. Now, what they're wanting you to do is find like the graph, the direction field graph, given this table that you just made. And so here, I'm going to start using different colors. I got 0, 0. I have a slope there of 0. So what I'm going to do at 0, 0, I'm going to make this little flat line. It's kind of like a mini slope. And notice I could make a whole line, right? But that would be kind of junky because I'm going to have a whole ton of these things flying around. So I'm just going to make a tiny little mini line wherever I have that. So same thing here, 0, 1. So 0, 1 is about right here, a little flat line. 1, 0 is located about right here in 16. So that's going to be a positive slope. Notice that it basically is just this, but I'm not wanting to do all of that line, just a little section of it. And then 1, 1 is right here, and it says it's a -16 slope. And if you keep on doing this, what happens is that you have these lines here that look like this. You even have some lines up here that do this. It's like artwork. Isn't that cool? This way. This way. There you go. So it looks something like this. And then what they say is, hey, we have y of 0 equal to 0. This is my starting point. And from there, I want to draw a specific graph. And so I'm going to go here and say, okay, well, that's where I start. And what I want to do is I want to follow the flow of whatever I see. Notice that right here I'm flat. So I'm flat for a little bit, but then it starts to come up. See the up? So I'm going to go up. But then see how these guys are going down and these guys are going up, and they're kind of like conflicting with one another. Well, what's going on is that I have to actually level out in between them like this. And the same thing on this side. Kind of like that, okay? This is the worst problem to start with, of course, but what you're wanting to do is follow the flow, kind of like a water thing. So you got water going this way, you got water going this way. Guess where the water is going to end up going? That way. Yeah? Wouldn't it go that way eventually? That's my point. Okay. If that didn't make a lot of sense, well, let's just do some more. So I'm not going to do the table every single time because it takes forever. But at least this problem here in particular is easier to understand. Don't know why this couldn't have been number one. So I'm just going to draw what this yields, by the way. And so it kind of makes this shape here that it's like flowing. That's going to be a straight line there. And then it kind of, these guys curl back. I don't know about curl back. I'm just going to say they do this here. Something kind of like that. Okay, so that's about what it's going to look like when you fill it all in. That would take forever, right? Well, my point is that A, B, C, or D, you're picking the one that makes the best sense. So, what's going on at 0, 0, right? If I plug a 0 in for these two guys, I get 6 times 0 minus 1 is a negative 1. Do I have a slope here, negative 1? Like, see, my negative 1 slope would be something kind of like this, yeah? At 0, 0. Well, here, does it look about right? Yes, that looks like a good graph. What if I had another graph where it did this kind of stuff? Is that negative 1 slope right there? That's like a positive 1 slope right there. So that graph here would not work. What I'm getting at is that you don't have to make a full table. Just make like a few points and then find out. Again, we said it was negative 1. This here makes sense with this graph, but not that graph. And so, this one doesn't work, but this one does. And then you can multiple choice and get it down to a good answer. Okay, cool. I want to show you what it would look like if they gave us specific points to work with. Say they had a specific point right here. What would it look like if I followed the flow? Well, it would do that, wouldn't it? What if I had a specific point right here? Well, it would basically just go straight down. And then what if I had a point over here? It would kind of flow like that. The point is that I'm following the flow of what's going on here. Okay? That's the flow. Okay. I'm going to like rapid fire the rest here because we need to get to something, I guess you would say like more applicable for you. So y prime is equal to sine of 7x cosine of 7x. I'm sorry, not x, y. And I'm sorry again, hold on. This is a sine. They're both sines. It's just that's the x and y. My bad. You might have a new randomization where it did actually do the other stuff. I don't know. Well, this is the graph. Looks something kind of like this. Flattens out. Flat line here. Bubbles down. Hold on. Bubbles down. A little bit right there. Flat line. There's your graph. Again, I want to show specifics. What if they said, hey, find a point starting right here? What would be the line that goes with it? Well, I'm just going to follow the flow. Right? Something like that. They don't ask, but I'm just saying. Pick that one. 92009. So I got y prime is equal to 7 halves y. Have we seen this before? Didn't I do this in a previous section? And what was the result? It was CEKT, right? Exponential growth. And so regardless of what's going on here, what you actually get is this kind of answer here. And, of course, the negatives as well. So what's going on? Why did I choose this one? Well, notice one of my answers, a specific answer, I don't know, say a 1 right there. And that k, we already have what k is. It's 7 halves. That's growth, positive. It would look like this, right? So my point is, find the one that looks like it would actually work for this situation. Now, that was a funny one because we knew this problem in particular, and so I can easily just choose it. Couldn't I still make a table, though, and see what graph makes sense? Sure. Okay, last one, 92013. So I've got y prime is equal to 3y plus 9xy, and they say start at 0.01 and graph it. So what this looks like is a whole bunch of parabola stuff. Something kind of like that. And then I'm going to graph mine starting at 0, 1, which will be right around here, and it would follow the flow kind of like this here. And that's my answer, pretty easy, no problem there. My particular graph that I have, it looks like it shifted. Maybe it was just a typo or something. I don't know. Just watch out. I don't know if I drew it perfectly or not. It's whatever. Okay. So that was the direction fields, and yes, that's great and all, but we really need to talk about Euler's method. So Euler's method is very applicable because it's talking about approximations of differential equations. So Euler's method, and I'm going to do it with this problem so I can show you what's going on. Again, it sounds like Euler's because it's German. So, well, there you go. They say I have a step size of 0.2, and that we have y of 2 is equal to 0. I got y prime is equal to 4 minus 2xy, and then finally y of 3 is what they want. Here's the thing. I have a slope formula. I have a starting point, and I want to get to this ending point. The idea is that I'm starting over here at 2 and 0, and I want to know what's going on here at 3. Is it up high? Is it down low? Is it super high? What's going on? And so what I have is a slope, and let's just say that I had a slope particular there. That was, I'm just making something up here in a second, that looks something kind of like this here on my direction field. And so I want to follow the flow. And I want to say, you know what, I bet it's going to be somewhere up here. I don't know exactly what that answer is, but my point is that as we get going, we're going to get closer and closer to our answer, and when we hit that 3, we should be good to go. Now, there's a procedure to go from 2 to 3. Notice that we got 2, and now we're going to 3. There's a procedure to get there. It's called the step size. And I'm going to step it by 0.2 each time. So right here, 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 here. And we recompute, calculate, see what the height is, and you'll see that the height keeps increasing. Again, my flow, it looks probably something like this all around it. And so I'm just going to be going with the flow of it. That's my idea. Okay, I'm just following the flow, just like what we did a second ago. Okay, let me give you some formulas. I got yn plus 1 is equal to yn plus h times y prime of xn yn. What? Let me give you the x formula too. N plus 1 is equal to xn plus h. So with these two formulas, I should be able to figure out what's going on. And this is recursive because I'm going to be taking the previous answer and plugging it in to be able to find out what's going on. This is a big one. So I'm going to actually do this one by hand. Literally just plug it into the formula, and we'll go from there. So here's some stuff we know. H is equal to 0.2. That's my step size. X naught is equal to 2. That was given to us right here. And then my y value, you can see, is a 0. So y naught is a 0. Given these guys and my y prime formula, which, again, they gave me that to me as well. This guy. Yep. I should be able to just plug it straight in. So here we go. My x1 is going to be equal to x0 plus 0.2. That is 2 plus 0.2 is equal to 2.2. So this is neat. We'll talk about that here in a second, but let's find y1. So y1 is going to be y0 plus, again, h, which is my 0.2, times the y prime formula at x0, y0. Well, I have y naught and y naught, y0. It's 0, 0.2 for my h. And then I have these guys as well. That's going to be a 2, 0. I'm going to plug this into my formula to get the result. Well, here's my formula. So 4 minus 2 times 0. Well, 0 times anything goes away. And I got 4 times the 0.2 makes a 0.8. And again, this is nice. What we just made is a new point. x1, y1. That's my new point. And so I can use that point to find the next point. So let's start with x's. So I got x2 is now x1 plus 0.2. Well, that's 2.2 plus another 0.2 equals 2.4. Again, the goal is to reach 3. The goal is 3.0. Okay, we're not there yet. Y2 would then be y1 plus the 0.2 times y prime of x1, y1. Plugging it all in. What I had was a 0.8, 0.2, and then as a formula, 4 minus 2 times, I had my 2.2 and my 0.8. Blah, 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 calculator, and I get 0.896. Again, this right here is my next point. 2.4 and 2.89, basically 2.9. What I can actually do here is I can actually graph this stuff. Like there's my 2.0, and I've got 2.2, 0.8. Again, this is my 3 I'm trying to get there. So 2.2, 2.8, there you go. I got 2.4, and then 0.9 is getting like way up there. Okay. And so on and so forth all the way up. You can follow the line, and what I'm wanting to know is like, hey, what's going on right here? And we're getting closer, but we're not there yet. Well, this will take forever to get down and figure out, right? Because I have to do it again for 3. I have to do it again, and then one more time, and eventually I get to 3.0, and we're done. Whew. Is there a better way to do this? Yes, it's called Excel. That's right. We're going to use Excel on this as well. Let me give you what I'm going to put in, and I'm going to demonstrate it. So A1, I'm going to put a 2, because that's my starting X value. And then A2, in the A2 slot, I'm going to say equal sign A1 plus 0.2. Like, this is literally what I'm putting in to my cells, okay? My B1 cell, I'm just going to say equals 0. But then my B2 cell, I'm going to put B1 plus 0.2 times, open, get a little bit of room here, 4 minus 2 times A1 times B1, close, and then all of this with the equal sign, got to have the equal sign. And I hit enter. And what you can do is you can drag this down, and you can get your answers. And eventually, when you get to 3, you'll see the 3.0 pop up down here. That'll be what their actual answer is that they want. Okay, so let's do that together and see what we get. Bloop. So again, I don't have Excel. I have LibreCalc, and it's just an open, well, it's just a free version, I guess you could say. I was trying to say Open Office. That's another version, I guess you could say. Not like Libre, free, open. Yeah, they're all the same stuff. Anyways, so LibreCalc, just like Excel, same stuff. Let's type it, see what happens, get an answer. So I'm going to say equals 2, or you can just put a 2. Either way is fine in this case. But then you must put an equal sign for this guy, A1 plus 0.2 enter. Now, I want to drag this thing down. See, I went too far. You can drag it back up. So 3 is basically where I want to stop. Okay, up here. Again, equals 0, just a 0, doesn't really matter. But this guy must have an equal sign here. B1 plus 0.2 times 4 minus 2 times A1 times B1, close, enter, drag it down, and there's my answer. Notice, didn't I get these answers here earlier? Didn't I get that one just a second ago? So we were on the right track, but notice that it kind of curls back down, and then we get a new number here. So my answer is 0.70801 or whatever. I don't know if they want 4, 5, or 10 decimals. Whoever knows with those guys. There you go. So that's my answer there. Cool. I'm going to use Excel on the other ones as well, and I'll try to write it like on paper, and then I'll actually do it, and then we'll get the answers together, okay? So let's do the next one. I find this pretty fun, so that's a good thing, right? H is equal to 0.1. I have y of 0.4 is what they want. They give me that y prime is equal to 3y plus 3xy, and they're starting us out at y of 0 equal to 1. So notice that we're jumping by 0.1, and we need to get to 0.4. Well, what we're doing is like 4 or 5 different jumps, and we should be done. And this is my crazy formula thing, so let's do this thing. My A1, I guess you could say this is just A column. I'm going to start with just A. I don't know why I wrote A1. A column. In row 1, I'm going to put a 0. Right, there's my 0. But then the next time I want A1 plus 0.1, and then I'm going to click drag it down. Okay, so for my B now, I'm going to start with a 1. Again, I got that 1 right there. Boom, good. For the next one, I'm going to want B1 plus 0.2 times, not 0.2, it's 0.1. I'm sorry. 0.1 is my step. Times, and then I got this crazy formula, 3 times B1. See, that's a Y, so that's a B. Plus 3 times, there's an X right there, so that's going to be an A1. And then this guy right here is a Y, so he's going to be a B1. Sorry, it's going like exponential growth. That's what I'm going to type. That's what I'm going to get. I've been trying to do my ones kind of silly-like so you don't get confused with, like, I don't know, a slash sign or something weird. So let's type it in. So I'm just going to delete all this stuff, start over. And so I got my 0, and I'm going to say A1 plus 0.1. And I want to drag that down. Yeah, 0.4 is where we want to stop, right? 0.4? Yeah, okay, so we're good. Starting with a 1 here. So equals B1 plus 0.1 times 3 times B1 plus 3 times A1 times B1, close. And then again, click drag it down. And there's my answer right here. And we're done. Like, that's it. The end of this problem. 3.268. 3.2685. There you go. We approximated this y value using the Euler method stuff. Okay. I'd love to show you more on the Excel side. It would be definitely not planned, but it would be pretty neat to kind of see what's going on visually. But that's in a few more minutes. So we got this electrical problem here, R times Q prime plus 1 over C times Q is equal to E. So we got resistance, we got some capacitance, we got some voltage, and all that kind of stuff here. I don't know what Q is supposed to be, some kind of flow or something. No, it's capacitance. Okay, yeah. 1 over C there, that makes sense. Okay. Cool, so what do we do here? Well, they got R is equal to 5 ohms. I have C is equal to 0.5 farads. I think it's farads or Faradays. One of those. E is a voltage. We got 80 volts. And what we have is they say find Q of 0.5. I believe that's a T value, like in time. So over time. And then my H is a 0.1. So, oh, and they give me one other thing. Q of 0 is 0. The point of this problem is not to learn electrical circuits and stuff. I'm sure that's really neat. But my problem is that I have all this stuff here, but I don't have my formula exactly. I don't have like a Q prime figured out. Well, my Q prime's here, but it's not exactly correct yet. It's not fully just Q prime equals. So I need to move this over and divide by my R to find Q prime. So E minus 1 over C Q all divided by R. Well, you know what's funny is that a lot of these I actually have actual numbers for. So like my E is 80. My C is 0.05. My Q is, well, I don't know. It's like an X value. My R is a 5. And so this right here is my differential equation formula. I should be able to plug in things into that and get an answer. Notice one thing, and this is very strange. Where's my X value? Where's my t value? Something like that. I don't actually have one. So when I type it, this guy here is definitely going to be my B1 in the formula kind of thing. But I don't have an A that's actually part of my formula. So just kind of watch out. It might seem like, oh, well, you know, I'm missing something, so there's something wrong. No, it's just kind of more, I guess you could say, simplified problem. It's don't overthink it. Let me show you what's going on. So I'm definitely starting at 0, 0. So 0, and then the next one is going to be this A1 plus the 0.1. That's my step, and drag it down. I don't know why I keep putting a 1 there. It's just B and A. Okay, so this guy, again, I'm starting at 0, and then I'm going to have B1 plus the 0.1 times, and then I got this crazy formula, 80 minus 1 over 0.05 times my B1, all over 5, close, and I think that's it. Drag it down, and there we go. So let me type that thing out and see what kind of answer we get. 0, 0, there we go, equals A1 plus 0.1, and then again I'm dragging this down. They want 0.4, they want 0.5. So one more, drag it down one more. There we go. This guy starting at 0, and then we got a B1 plus 0.1 times 80 minus 1 divided by 0.05 times B1, and all that divided by 5. It should still work. Click, drag it down. This is my answer right here, and I'm done. Like, that's it. So 3.69. I think 2 decimals is fine because that's what I have for some reason. 3.69. C. Maybe it's not capacitor stuff. Maybe it is. I don't know. So what is a C? Coulombs? Columns? I don't know. That doesn't sound right. Something's wrong. Anyways. I'm not an electrical engineer, so... I just do the math. There we go. Cool, man. That was so cool. So 92028. This is a Newton's law of cooling problem. I got 90 degrees Celsius, coffee, sitting in a room that is 20 degrees Celsius, and it says that it cools at a rate of -1 degree Celsius per minute when it's like the coffee is sitting at 70 degrees Celsius itself. Let's talk about this. So I got 90 degrees here, and it's going to limit itself to 20 degrees here, and it's going to kind of level off down to 20. So the formula, the answer to doing any of this is very simple. It's 70e to the negative kt plus 20. We can solve for k, and we're done. And that's it. Cool. And so, hey, where did we get to the 70? Was it over there? No. The 70 here is the difference. And so what this actually is the original 90 minus the 20 degrees of the room makes the 70 degrees right there. Okay, that's the difference right there. Not this one. That's a whole different problem. We'll have to talk about that here in a second, okay? Our problem is that we need to solve for k. And what they gave us here is a rate. This is my y prime, and this is a y value, and it has nothing to do with t, and so I'm kind of confused about how to find my k and keep going on this problem. So what I want to do is find my derivative of this guy right here. In order to do that, I say derivative. I got my now negative 70k e to the negative kt, and the 20 goes to a 0. Very important, those little things like that. Change everything. And so this isn't super helpful because I still need to plug into 70. Oh, I'm sorry, -1. And I want to plug in 70 here, but there's nowhere to actually plug it in. And so I'm kind of lost. I'm like, I don't know what to do now. Well, here's the thing. What I need to do is go back to my original here, okay? And I'm going to solve for y. And so how I'm going to do this is I'm going to plug in a y for this guy right here, and then everything should simplify, at least I hope. Move the 20 over, divide by the 70, so I got y minus 20 over 70 is equal to e to the negative kt. Now you could solve for t, but I don't think that's going to help because what I'm doing instead is taking this and plugging it in directly right there. And so now I have a y prime is equal to negative 70k times, now all this stuff, y minus 20 all over 70, and then plus 0. Again, I could just get rid of the 0 at this point. The 70s actually cancel one another, and so we get a y prime is equal to a negative k, y minus 20, and that's nice and beautiful. Now I should be able to plug in that negative 1 degrees Celsius is equal to negative k, y was equal to 70 in this particular case. It's not the same 70, not the same 70. And so I got a 50 here. Divide it to the other side, two negatives are cancel, so my k is equal to 1 over 50. Awesome. Now I can finally say y prime is actually then equal to, like going back to this guy right here, a negative 1 over 50, y minus 20, and there you go. This is almost a formula, almost, and that's a good thing. So that's my first answer. They now say, hey, we need to have a limiting size or limiting factor or something like that. What's the limiting whatever? Well, this is going to be the 20 degrees Celsius. That's the room temperature there. And part C, so that's part B. Part C now says use the Euler's method for h equals 2. And I had my initial point, again, was, hold on, I'm looking through all my notes here to figure out where I was. There we are. Y of 10 is what they're actually looking for. So what I want to do is my A column, I'm going to have it start at t equals 0, and I have an A1 plus 2, and I'm going to drag it down. In my B column, I'm going to start with my 90 degrees, because that's 90 degrees at the very beginning for my coffee, is now equal to B1 plus 2 times my y prime formula, which is this right here. So then it would be the negative 1 over 50, and then y is a b1 again, minus the 20, close, close, and it should be good to go. Drag it down. Whenever you meet the 10, look over, get the answer, and here we go. So I already tried with something else. That was an old attempt, and I've already done this. I've already done this problem about 10 times today, it seems, and that's okay. I want to get it right. So if I'm feeling like, oh man, he's going kind of fast on this problem, it's because I've done it a whole ton of times, and I've done it wrong a whole ton of times. So I hopefully this time, it'll actually be right. And so plugging in for this guy here, again, I'm missing my page. There we go. Okay, cool. Finding my formula. So I got now my B1 plus 2 times, and let's go back and verify here. We got this 1 over 50 business. Negative 1 over 50 times B1 minus the 20, close, close. Click, drag it down. That's a good number. So that's your actual answer, 77.08. And that's what I got in my notes. And that's a good thing. It's a good sign. Okay, cool. I would keep going. I tried going into all these cool, like, hey, this is different than what this exact stuff is, and blah, blah, blah. I'm not going to go through any of that because it was just a waste of your time. So this is your answer. Pop it in. There we go, and done. Thank you very much. Have a great day.